This series of videos is meant to walk you through pages 21 and 22 in your packet, which is about graphing the sine function. I'll start with a quick disclaimer that much of the material on these two pages is actually meant to kind of be self-explanatory and was meant to be done a little bit more independently, meaning that you don't really have to learn anything new per se to be able to complete the questions. It's mostly just asking you to explore stuff on your own, to try things or to make observations using knowledge that you already theoretically have. Now, of course, I know that might be easier said than done in some cases, especially if you feel like you don't really very well understand some of what we were doing while we were last in class. So the purpose of these videos is to walk you through each question if you feel like you genuinely don't understand what it's asking. If you feel like you can answer the questions without needing a walkthrough, I would recommend that you avoid the videos, or better yet, just watch the videos for the 1 or 2 parts that you might be stuck on, and otherwise try to do the rest of them on your own. As you know, sometimes I explain things longer and in more detail than people need. So if you're one of those people who tends not to need a full explanation, you just want a couple of quick details and then be done, then I would recommend that you avoid some of the videos, fast forward things as needed, or just do whatever you can to get things done expeditiously. Because I do think much of this material can actually be done on both pages without my explanation needed. Now, of course, if you do want to follow along with the explanations, I'll go through each question one by one, figuring that if you have any questions whatsoever, you can always send me an email and I'll be glad to clarify. As you're working through with me on page 21, keep in mind that it might be helpful to have 2 resources if you have access to them. First, a unit circle might be helpful to refer to, just in case we refer to a number that you don't quite have a good visual for in your mind's eye. And second, if possible, a calculator. The calculator can sometimes come in handy if you have one. If you don't own a graphing calculator like this one, that's okay. Even just a regular calculator on your phone can do the trick. Just keep in mind that sometimes the default calculator on your phone doesn't work too well with complicated functions unless you turn it sideways. Oftentimes, if you turn your calculator sideways, you'll see a bigger display with more buttons, and that's usually where you can find things like sine and cos, and you can also change the mode. Remember that idea between radian mode and degree mode? Your calculators on your phones can often do that same change. So if you have a calculator, definitely use one. If you don't, I'll display mine on the screen anytime it comes in handy. Now, the first question, question number 1, is going to ask you to think back to the Ferris wheel that we were doing way back at the beginning of the chapter when we were first getting introduced to the unit circle. The Ferris wheel is basically an above ground, below ground setup where all of the values in the first 2 quadrants were thought of as above ground, and all of the values in the bottom half of the circle, or the last 2 quadrants, were below ground. So as we work through each of these questions, try to picture that original Ferris wheel that we were playing with. Remember the one with the spinny seat that you could spin, and we measured a bunch of different heights? We now know that all of those heights are called sine values. We now know that they were actually special right triangles, so there were much more efficient ways to figure out the heights. We were measuring with those crappy little rulers and realizing that those measurements were very tedious and not even accurate. So we've come a long way since then, but the mental image of the Ferris wheel might be helpful to keep in your mind's eye as you're answering each of these questions. For example, in question number 1, if you think back to the actual trigonometry that we were doing before we really learned a whole lot about the special right triangles, we talked about the idea that we were actually measuring sine functions. And as a reminder, it was because when the angle of our little right triangle was positioned, the angle in the corner here made the height an opposite. And since we knew the hypotenuse, opposite and hypotenuse was a sine function. So as we're answering each question, you may not remember back to when we did these originally, but I'll try my best to kind of ask you, if possible, to think back and remember as much as you can, because that was one of those details. And if you forgot, but you still have your packet, you could always go back and refer to the original page where we did some of these conversations, and that was page 5. Page 5 has all of the original data that you collected and probably some evidence of your calculations as well. So go back to page 5 if you need to jog your memory a bit. Now, in letter B, it says, what's the height of a seat at the pi/6 position? At the time we did our original circle, we didn't even know what pi/6 meant, but now we not only know where pi/6 is, that's at this spot, we know how to quickly get a height. The height would be the vertical. This is the shortest vertical, so its height must be 1/2. Same thing goes for √3/4. √3/4 is over here in the second quadrant, so I'll give you a couple of seconds to see if you can do the height. I'm not going to write it or say it, but I'm going to challenge you for about 5 seconds. Picture that height. Think about short, medium, long, positive, negative. Did you get an answer? If so, go ahead and write it in letter C. All right, so I'm going to kind of do that I just did there, where I'll write some and then I'll ask you to independently do others. And if you feel like you're second guessing yourself, or if you're like, no, Herbert, I really need the answer, you can always open a separate tab with the answer key, which is posted on our learning plan, and you can check your answers as we go. I'm just going to try, if we can, to mimic the class time experience, where I give you some of the answers and you do some on your own, so that you can keep that sort of back and forth. Watch me and then you try it yourself sort of vibe that we normally do in class. Now, in letter C, you probably got an answer that was kind of tricky to think about as a real number. It has a square root in it, it's a fraction. It's not easy to think of that answer as a real number, probably because, and I'll say this quite frankly, it looks weird. And I have no problem writing that, because I'm sure that if you look back at your own answer in that spot, you would say, ooh, it does look weird. Ooh, I'm really not sure what that number is. So, in terms of understanding that number, in terms of turning it into a value that actually has some meaning, the calculator can really come in handy. Because if you can type that number into your calculator, and I'll just do an example. This is not the number that you got, but I'm certainly just going to do it as an example. You can convert it to a decimal by typing in the number, if there's a square root, divided by whatever's on the bottom, and you can get a decimal. Now, 0.88 isn't very nice as decimals go, but at least that's something I can picture. Like, I can picture how much 0.88 is. If you told me to graph it, I could picture where 0.88 is on like an x-axis. I can't really picture where √7/3 is. That's just not a number I can conceive of. So, in terms of making values easier to understand, consider converting to decimal form. And again, that just means type it into a calculator and let the calculator do that conversion for you. Now in question letter D, it's asking you to describe 2 different ways we can find the decimal approximation of the height at 4pi/3. So I'll look at my circle, 4pi/3 is here, and if I want to get that height, I can tell once again this is going to be an ugly number. This time I'll do this one for real. This ugly number is going to be the longest in its quadrant. So if I look at the long, that would be √3/2, but I'd have to go down, so that's negative √3/2, which again is a pretty weird number. That's a number that's hard to conceive of. So if the question says describe 2 different ways we can find this decimal approximation, let's see if we can go ahead and think creatively. One way I can do this is to use the calculator resource that I just discussed. So if I typed, for example, negative, and actually let me brighten my calculator for a second. There we go. If I typed negative square root 3, then divided by 2, now I can see a decimal, negative 0.866. That I can conceive of. That's easier for me to picture. So that's one way that we can find a decimal approximation, is to type negative √3/2 directly in the calculator. You'll notice I'm saying the answer to the first answer space here, but I'm not writing it, just because I tend to write and talk really slowly, because I can't do 2 things at once very well. So if you're hearing me, you might as well maybe pause the video, copy down what I'm saying into the space for number 1, and then resume the video once you have time. Otherwise, if you're like me and have trouble listening and writing at the same time, it might get kind of overwhelming to fill in these spaces. So we know one way is to convert the number in our calculator, but another way is to think about the trigonometry. Remember how we said that these values, these vertical values, are sine values? We could, if we wanted to, actually just type sine and then 4 pi over 3. Now, interestingly, 4 pi over 3 is a radian number, so our calculator would have to be in radian mode for this to work, but I can quickly change my calculator to radian mode, and then I can type 4 pi over 3, and sure enough, notice what my calculator gives me, the exact same value as I got for root 3 over 2 when I put it as a fraction. So that's a second way that you can get a more familiar decimal, is you can type sine into a calculator. Now, of course, this method is only convenient if you have a calculator, but at least if you have an option of using a calculator, it gives you something that you can do. Now, once you have that, question letter E is actually something I think you can do. Question letter E says fill in this table using both the exact values and the decimal approximations of each of these values. The decimal approximations are usually going to be really big, ugly numbers like the ones that you saw here. So rounding to 2 places, which is the nearest hundredth, is appropriate so you don't have to write big, awful numbers. Now, this is where I'm actually going to end the first video in the hopes that between the end of the first video and the beginning of the second video, you can take some time to independently fill out this chart. I'll do an example with you just to make sure, but once you know what to do, I'm going to encourage you to do it on your own so that you can understand where the next video is picking up. In question letter E, the number I'm going to pick is pi over 4, just for the sake of trying something that looks a little different. So where it says exact value, I'm going to do what I always do. I'm going to find pi over 4. It says specifically sine, so I'm going to do the height at pi over 4. That would be the median length, so root 2 over 2. That's what we call the exact value. The decimal approximation I can get, again, 2 different ways. I can either type square root 2 divided by 2 into my calculator, and it can give me a decimal, or I can type sine of pi over 4, and I can get the same decimal. Either way, the decimal is going to round to 0.71, so I'll write that as my decimal approximation. Again, depending on what calculator you have, you may or may not be able to do both of these methods, so try to pick the method that works best for you. If you don't have a working calculator at home, you can actually go to Desmos. The specific address, and I'll write it here so you can use it, is desmos.com/calculator, because Desmos actually works as a normal calculator, not just a grapher. If you type into the left-hand side of Desmos, where you would normally type equations, it can actually do basic calculations for you. So if you need to, you can always use desmos.com/calculator to help you through. While I end this video here, I'm going to expect you to have filled in all of the values for this table in letter E, and if possible, try to also answer question letter F, because letter F is actually just going to ask you about the bottom half of the circle. This table takes you through the top half of the circle, which is from 0 to pi, and question letter F is going to ask you to think about from pi to 2 pi. That's just the bottom half. So it's not going to ask you to recreate an entire table for the bottom half. It's just going to ask you, how would the bottom half be related? Why would it be unnecessary to actually have to redo all of this work? What's the connection? When we start the next video, I'll start question letter G. So try, if you can, to finish everything through letter F before starting the next video, and use the answer keys to help you check your answers.